I am going to do a little video for you guys to answer some of the questions that you guys had for me last week before we took our test. Some of those questions I emailed you guys back and we discussed, and then there were a couple of things that didn't really need to be addressed before the test, but I want to address them now, just so that your guys' questions, we make sure that they get answered. And then there's a couple of other things that I noticed on the test that we're not getting right, and I want to make sure we address that now because it's a pretty important topic. So there are like 8 overarching standards that we try to address in every math class. So one of those is attention to detail, or attend to precision, I guess I should say. That's what they actually, those are the words that they use. Attend to precision. So making sure that your answers are precise, making sure that you're giving the right type of answer. So if you are asked for an exact answer, then you need to give an exact answer. It's not a suggestion, it's a requirement, okay? And if you're asked to round to the nearest 10th, then you need to round to the nearest 10th. So just following the directions and giving the right type of answer is important. So we're gonna start with that. That's something I noticed on the test with the ones that I've graded so far, that some of you either don't understand the difference between the two or just didn't think it was important to give the right type of answer. So I am going to make myself a little bit smaller here. Move myself over. Okay, so I am going to work out, this is, these are my notes to myself of things we're gonna look at. I'm gonna work out number 5 from the test that you took last week. Okay, it was a pentagon and you were supposed to find its area. Okay, and you knew that the side length was 8 inches. All right, so we know to find the area of a regular polygon, we always do area equals 1/2 PA. Okay, and we know that our perimeter will be 8 times 5, or 40 inches. Okay, it did say in the directions that assume shapes that appear regular are regular. So we're assuming that this is a regular shape. If this side's 8, all sides are 8. So 40 inches is our perimeter. And then we have to figure out our apothem. So we draw it in and we create a right triangle and we figure out the angle measure. That angle measure is going to be 360 divided by 10. And the reason I'm dividing by 10 is because I can fit 10 of these right triangles inside my pentagon, 2 on each side, okay? So that tells us that this is 36 degrees. That means this triangle is not a 30, 60, 90. It's not a 45, 45, 90. So we're gonna have to use trig, okay? Remember, the entire side length is 8, which makes this part 4. From the angle, that is the opposite side. And I want to know the adjacent leg, okay? Opposite and adjacent go with tangent. So we're gonna say tangent of 36 degrees is opposite over adjacent. And then to get A by itself, we're gonna have to multiply both sides by A. Okay, here's A now. It's still not by itself. I need to get rid of tangent 36, which is just a number being multiplied by A. So I'm going to divide by it. So we end up with A equals 4 over tangent 36. That is your apothem, and you should not round it at this point, okay? Because if you do, your answer at the end is going to be less accurate than if you waited till the end to approximate, okay? And I'll explain why that is here in just a second. So we're just gonna plug in 4 over tangent 36. That is the apothem, okay? And then we are going to simplify. So we're gonna take half of 40, which is 20, and then 20 times 4, which is 80. So 80 over tangent 36. This was inches, so that would be inches squared. And that is your exact, most simplified answer. And that is what you were asked for. So this is the only answer that you should give me. This is exact, and it's simplified all the way. It's exact because I haven't rounded anything. If I plugged this into my calculator, I would have to round it, and then it's no longer an exact answer. So this is your answer. Now, let's pretend for a second that it said round to the nearest tenth. It did not say that, but if it did, we would then plug this into our calculator, and we would get 80 divided by tangent 36 is approximately 110.1. So that was the approximate answer, but I did not ask for that, so you should not have put it down. Now, what would happen if you rounded this number in the middle of the problem instead of waiting till the end to round? Here's what would happen. You would get approximately 5.5 right here. And then if you go and plug in 5.5 times 20, it's just going to come out as 110 or 110.0, okay? Which is not the same thing as 110.1. It's off a little bit. You're not as accurate as you could be. And sometimes that's like a very minute example of it being off a little bit. Anytime you round and then use that rounded number to calculate something else, you're taking a rounded number and you're multiplying it by 20, okay? So the amount that you rounded gets multiplied by 20. So it gets like worse and worse and worse whenever you do something to the number, okay? So we never round in the middle of a problem. Your answer will not be accurate, okay? So you have to wait till the end. And again, I did not ask for a rounded answer, so we wouldn't give a rounded answer here anyway, okay? All right, now we're gonna move on to the quiz that you took before the test. So there were 2 questions that a lot of people asked about. So number 10 from the quiz. Okay, this was a very challenging problem. It's definitely a stretch question, an honors level question. It was worth 3 points, and I would say most people got a half a point. Okay, so it said the sides of an isosceles trapezoid are in a ratio of 2 to 5 to 8 to 5. So I drew myself an isosceles trapezoid. And again, the sides are in the ratio 2 to 5 to 8 to 5. So this is 2x, 5x, 8x, and 5x. And most people got that. Now, why are we putting the x's there? They did not say that the sides were 2, 5, 8, and 5. They said they're in that ratio. So they could be 4, 10, 16, and 10. Okay, that is a 2 to 5 to 8 to 5 ratio. So we put the x there because we don't know what the sides are. We just know they're in a 2 to 5 to 8 to 5 ratio. So I've put them in that ratio. Okay, the trapezoid's area is 245 centimeters squared. Find the height and the perimeter of the trapezoid. Okay, so we know this information, we know this information. We're supposed to use that to find the height and the perimeter of the trapezoid. So first thing I'm going to do is draw in my height, okay? And I can do that over here as well. Since this is an isosceles trapezoid, it's symmetrical, okay? So this triangle here is going to be the same as this triangle here, all right? If I have 2x up here, I have 2x down here. And then these are the same. So those are 3x and 3x for a total of 8x, okay? This has to be 2x, and then these have to be 3x for a total of 8x. Now I need to find my height. So I'm gonna do the Pythagorean theorem. So I'm gonna go 3x squared plus h squared equals 5x squared. And a lot of people attempted to do that, just didn't do it successfully. You have to have the parentheses because you're taking 3x and you're squaring it. You're squaring the whole thing. So it becomes 9x squared. and this becomes 25x squared. And then you'll subtract 9x squared from both sides, and you get h squared equals 16x squared. And then you'll take the square root of each side, and you'll get h equals 4x. The square root of 16 is 4. The square root of x squared is x. So my height is 4x. So you got a half a point for labeling the 2x, 5x, 8x, and 5x. You get another half a point for figuring out the 4x. Okay, and then from there, we're going to write an equation. We know area is 1/2 height times base 1 plus base 2 for a trapezoid. They gave us the area. It's 245. Okay, we now know the, I'm going to leave the units off for right now just because it'll get complicated. We know the height is 4x. We know one of the bases is 2x and the other base is 8x. So I have now plugged in all of my information and I'm going to solve for x. So half of 4x, that's just 2x. Inside the parentheses, we have 10x. Multiply those together, you get 20x squared. Now let's divide both sides by 20. We get 12.25 equals x squared. And then we take the square root, take the square root. And we get 3.5. Okay, so there was another half a point for writing the equation, another half a point for getting the 3.5. Okay, and then the last two, again, I said this was worth 3 points, so here was 1 point, 2 points, and then the last half a point is for the height. Okay, the height is going to be 4 times x, so 4 times 3.5. We get 14. Okay, that would be centimeters. So that's worth a half a point. And then here's the last half a point, and that's the perimeter. So the perimeter, if I plug in the 3.5, 2 times 3.5 is 7. 5 times 3.5 is 17.5, so I get that on the right side and the left side. And 8 times 3.5 is 28. So I have to add up 7 plus 17.5 plus 28 plus 17.5. And we get 70. So that's the last half a point. Okay. Another question that you guys asked a lot about was number 12 on the quiz. Okay, number 12 on the quiz. We had like a square inside of a square. Okay, and we were told that the area of square ABCD is 100. So when we do length times width, we get 100, and it's a square. So that means this side is 10 and this side is 10. Length times width would be 100, okay? Quadrilateral MNOP is formed by joining the midpoints of ABCD. So this is a midpoint, a midpoint, a midpoint, a midpoint. If this is a midpoint, then that 10 has been cut into 5 and 5. Same thing's happening here, and here, and here. Okay, and a square has right angles at all of the corners. All right, and so then I can see that I have a right triangle. It's actually an isosceles right triangle, also known as a 45, 45, 90. This is n, this is n, this is n square root 2. Okay, some of you did the Pythagorean theorem to figure out this side. You still got 5 square root 2. Or you might have gotten the square root of 50, but that simplifies to 5 square root 2. So then you had 2 questions. What is the area of this small shape? Area is length times width. Okay, and 5 times 5 is 25. Square root 2 times square root 2 is just 2. Okay, so you end up with 50. Or you can put it in your calculator. Either way, you're going to get 50. And then the perimeter is 4 times 5 square root 2. Or you could take 5 square root 2 plus 5 square root 2 plus 5 square root 2 plus 5 square root 2. Okay, either way, you get 20 square root 2. So those were your 2 answers. So it was worth 3 points, 1 for getting the 5 square root 2, 1 for getting 50, and 1 for getting 20 square root 2. Okay, one more question that I wanted to answer was number 36 from page 654. A lot of people asked about that. So let me pull up that assignment. Go away, go away. Okay, so here's the problem. Number 36, it says, think about a plan. Nina designed a semicircular arch made of wrought iron for the top of a mall entrance. The 9 segments between the 2 concentric semicircles are each 3 feet long. What is the total length of wrought iron used to make the structure? Round your answer to the nearest foot. So we have a semicircle of wrought iron. We have a bigger semicircle of wrought iron. And then we have all of the little rungs that connect them. So in total, how much wrought iron do we have? What's the length? Okay, so I'm gonna draw a quick picture here. Okay. All right, so to do this, we're gonna have to find the length of this arc, okay? Our formula for length of an arc is A over 360 times 2 pi r. Okay, that's a formula that was on your formula sheet. And this A stands for arc degree measure. So this arc's degree measure is 180. Okay, so we're gonna go 180 over 360 times 2 pi and then the radius. You can see here that the diameter of this semicircle, okay, there's the rest of the circle. The diameter is 20, so the radius is 10. Okay, 180 times 2 gives me 360. So that cancels with the 360. And we just end up with 10 pi. Okay, now I need to find the length of the other arc. So the length of the other arc, I'm going to use the same formula. Okay, it's still 180 degrees because it's a semicircle. But my radius is different now. The radius of this bigger circle or bigger semicircle, we've got 10 here, and then each of the rungs it said was 3 feet. So we have to add on another 3 feet. So the radius is 13. 10 here plus 3 more. Okay, again, the 180 times the 2 gives me 360, which cancels with 360, and we just end up with 13 pi. Okay, so total length is 10 pi plus 13 pi plus, let me double check, I think there were 9 rungs. Let me see here. Yep, 9 rungs, and those are each 3 feet long. So we're gonna go 9 times 3 feet, okay? And then we end up with 23 pi plus 27. Let me add those together and we're supposed to round to the nearest whole number. So 23 times pi, enter, plus 27, and we get approximately 99 feet. Approximately 99 feet. Okay, and then one more thing. I'm going to do a couple of problems from that 10-4 worksheet because, again, several people had questions about those. that is right here. I'm going to do number 12 and number 13. So the thing you have to remember here is that the area of a regular nonagon, it says it's 34 meters squared. What is the area of a regular nonagon that has sides 5 times the size of the smaller nonagon? So if the sides are 5 times as big, that means the scale factor is 1 to 5. Shoot, I hate when it does that. Don't know why it does that. Okay. Okay, so the scale factor is 1 to 5. That means we learned that if the scale factor is A to B, the ratio of perimeters is also A to B. But the ratio of areas is A squared to B squared. So the ratio of areas is 1 squared to 5 squared, or 1 to 25. Okay? So I know that 34, that's the small area, over the big area, okay, the ratio of areas should be 1 to 25. Okay, so then I cross multiply. A equals 850. That would be the area, okay? And I forget the units, if it was feet squared or meters squared or whatever, okay? And then I'm also gonna do number 13, and then we're gonna call it a night, call it a day, whenever you watch this. Okay, so number 13, it says a town is installing a sandbox in the park. The sandbox will be in the shape of a regular hexagon. On the plans for the sandbox, the sides are 4 inches and the area is about 42 inches squared. I just jot that down really quick. Okay, and then the actual area of the sandbox will be 168. It wants to know what's the length of one side of the sandbox. Okay, so we need to remember okay, the ratio of areas is 42 to 168. Okay, those are the areas they gave us. I am first going to simplify that. Okay, so let's see. I think both of those are divisible by they're both divisible by 42. So this is the same thing as saying 1 to 4. Okay, the ratio of areas is 1 to 4. That means the ratio of sides, or the scale factor, let's just call it scale factor. Okay, remember on the previous problem, we went from scale factor to ratio of areas, and we had to square it. So if we're going from ratio of areas back to scale factor, we need to take the square root of it, okay? So our scale factor is the square root of 1 to the square root of 4, or 1 to 2, okay? That's our scale factor. So if the sides of the smaller shape were 4 inches, okay? The sides of the bigger shape, they need to be in a 1 to 2 ratio, okay? A 1 to 2 ratio. So the sides of the bigger shape would be 8 inches, because that puts the sides in a 1 to 2 ratio, okay? All right, so I think that's all of the questions I was asked have been answered at this point. So I hope you guys got some answers, and if not, if you still have questions, please let me know, so that we can make sure that you guys are feeling good about everything that you're supposed to know, okay? All right, thanks guys.